ID as part of the path, the URL location of the browser. So let's see. Let's take a look at the code, right? That's not the code. That's part of... those are two windows that are open right now. And yeah, there's this thing that if I start it, then it will connect on both ends. It will connect, but and it will say, oh, I am replica 1, and this guy will say I'm replica 2. So that's progress, but there's still a bunch of stuff that we need to do at the network side, because when I enter an operation here, well, first of all, it says socket not ready, so there's clearly an issue there. And then if I yeah, we get connected, that's good, and I can create an operation. But then when I try to send something, it still says socket not ready. So there must be still some problem in the code. So let's go take a look at the code. All right. So the code main function is here, and it does a few socket initialization things. So we refactored last time to have an init function that's going to pass a socket to us, and we return a socket, and then we pass that socket then to our right. So we don't pass that socket at all right now. What we've done is that we have this kind of example code where we started to move from a event like what's in the pure functional programming language sometimes can be called pointwise, which is that instead of considering streams, we consider each of the stream elements, and which is kind of what we do here. We send individual operations as we receive them, as opposed to actually not even looking inside the stream and just sort of connecting them together, which is this style here. And in this style, we use a different library, which is the Node coroutine library, together with what, the Node stream library, I believe. And so this gives us this style where we're able to pipe streams together, including streams that come from Node. And in fact, that was pretty nice to see that not only streams that come from Node, but also streams that actually just have the same API as a Node stream. And it just happens that in the browser, we use libraries that actually basically don't use yet the future web API web streams that will exist in the browser more widely. They use a shim or something that looks like Node streams and that has similar method. And the fact that they do that means that we can just simply reuse them with code that was actually written for Node streams. So that's super awesome. I hope we're not going to encounter problems with that, but we shall see. And what else? Well, so I think then we had this style of just having a socket and just piping it, or like creating a pipe and then instantiating the pipe, and then once the pipe is instantiated, then any event that comes into the socket will be read, transformed to uppercase, and then output back to the same socket. With this language, with this combinator, transform producer and connect. So here we start being in a kind of a more of a, if you know Haskell, pipes or conduit style programming. With this right here, I think what I do is that I'm using the coroutine. Is that right? Hold on, like readable and writable come directly from the coroutines. So this is already coroutine like. Where is write string coming from? Write string might come from node streams. Let's see. Node buffer. Okay. Oh, and node streams. Okay. Takes a writable with some encoding. So the writable is the socket, and the encoding is UTF-8. We pass it hello, and then doing this should then make this socket read something, allow it to pass to this transform to upper, and then write out the socket. And so this should mean then that we have hello somewhere. Unless it's not working, which is possible. Yeah, it could be that this socket not ready is related to this. So this is where we are at. And I suppose there's to make this coalesce, I'll try to focus on small bits. And then what we'll need to do is rewrite this send and receive functions in a way that will fit these new, more streaming APIs. Okay, let's see. I'm going to drink some water. Actually, you know what? I'm going to go and make myself a little bit of a juice. So I'll just be out for just a couple of minutes. Oh yeah, juice is delicious. Okay, so let's first try and understand where the error occurs. And let's see, is this going to rebuild? It looks like it isn't. Okay, spago minus w build. Is that right? Spago build minus w. Okay. So swarm connected, or swarm was created. Then we see a new connection. Prints the replica ID. And then probably does some send and receive, but I think basically we need to do this before, basically. If you want to test this, we need to run it at times, and yeah, our connection is right away. And what else? So does this get stuck? Looks like it does. Okay, let's bisect. Okay. So that works. So this, it could be that this actually creates a loop and that we don't want that. So maybe can we pretend? Yeah, let's try and pretend that yeah, that's, I think that's, I try to do something like this to pretend that console was a stream and then pass it something, but visibly that's also not working. I don't remember what, I think we made that work before, but I don't remember what the version that worked was. I think we weren't using socket. That was part of it. So how, maybe is this supposed to be blocking some way? Yeah, to completion. Yeah. The fact that it wants to run to completion is a little bit suspect. Feels like we might need to fork this somehow, or which might be possible with run off. But let's see what an idiomatic way to use this is by hoping that there will be an example in the library. The test at least. Yes, so current process showing use co-transform co-showing. Oh. Okay, printer. Ah, I kind of like that. So they use launchaf instead of runoff. Let's also double check what the difference between those two are. Forks enough from the effect and runoff. Forks enough from an effect context. Also takes a callback to run it when it completes. So showing is forever. Fuse co-transform co-showing. That will go to from 0 to a limit that is 100. And then it will stop. So I think, yeah, I think this showing co-showing example, you know what, we can actually run it pretty much without necessarily a lot of effort. So let's do it. Except for the qualified import, but you know what, I think we can, won't matter too much if we have duplicate imports, and then we can run these things. Probably just simply even before we do the socket stuff. Conflicting for log, class console. Yeah, that's fine. We can. They're the same in effect. And what's the, didn't look at the first error. Ah, well, that was it. And yeah, it definitely finishes it does an interleave, right? It does the 100 and then it does another 100. So the first 100, let's remove those. Um, um, so yeah, so I think it's getting stuck right here. So this, if let's see, how are we gonna do that? Because that makes sense. In this idiom, you have basically an event loop of sorts, right? So either we find some way to interleave things, which is an interesting thought, because we could also up the NTs and go in the further tangent, but the productive tangent, where we run this in a web worker, which kind of makes sense to have a basically a kind of a IO dedicated loop into its own web worker. Possibly. Or can we try to somehow incorporate this here? I think that's not easy, because there's an impedance mismatch, right? I mean, clearly this library is not really a streaming library. It's actually not even an FRP library. And so we'd have to do something smart with basically the control there, because the control here goes to attach, which is responsible for basically tying the knot, and after setting up all of the subscriptions for the JavaScript browser events for clicking and so on, then to use each of these events coming in as a potential state change, and in our case also side effect execution. So we're really really not in that paradigm so much. So just seeing this impedance mismatch between the library that we've chosen and this more streaming orientation that I'd like to start going towards, we're gonna be in trouble. So I think it makes sense to maybe go for and look for another library for that will make kind of a streaming paradigm more easy. I mean, the other option, okay, now what comes to my mind looking at this is this idea of the comonadic UI. And because I'm thinking it's possible. Well, I've actually already done a little bit of thinking about that. I would need to refresh my mind about it. But some of the idea is that the free co-free so let me explain just a little bit about this. It's not easy to do in a nutshell. It's one of some of these very high level abstractions, and actually let me Chris Penner Twitter and Path 31 and comonadic UIs. this should actually, the co-update comonad. Images. Chris had an interaction with Path not so long ago, asking specifically about this comonadic QY thing, and it could be that actually Path is Phil in here, or is he? He's also Path, but I'm not sure the search is going to work for me that way. That might be it. Go up the comonad apply. That's the paper. What about the slides? Yeah, that's what I'm looking for. And this is the important bit coming up here. So this is what's in this blog post. And it's about this idea of pairing and the fact that each pairing of this specific data structure, one of which is a monad and the other is a comonad, corresponds to existing patterns of how UIs deal specifically with basically things happening which basically are actions or events triggered by the user and how the program reacts to them. It's close to what that pairing is in sort of event terms, or like it makes me think also of how Cycle.js defines its kind of its main loop of like the responsibility of the program, which takes events as sources and then it emits event as sinks, and then the responsibility of the outside world or representing the user to emit new events and to interpret those outputted by the program, which is something that's also discussed, I think. Where is it? It's a model view, a dialogue abstraction. Yeah, talking about a dialogue abstraction, right? It's like you have this mapping of the computer, which has output and input, and the human, which has senses and actuators, right? And so it is a fairly similar duality going on here, but level of abstraction significantly higher, because first of all, it abstracts beyond streams, even though it doesn't hint at streams directly here, but there's actually a connection between comonads and streams. And so React, for instance, one of the ideas that the comonad represents the space of states. So all of the possible states that your application can transition from and to, and that the thing that make them transition are the things that you pair with. And so an event can be interpreted in terms of I do this, and then the action, the monadic action, excuse me, and that might in some sense correspond to a trajectory or a degree of freedom in your state space. And all this pairing represents something a little bit like that, but with one that's pretty abstract. That's the free co-free pairing. Because the free co-free pairing, then for me, actually, it helps me see this even more clearly, because in the free co-free pairing, each of your monadic action in the free monad are a component, in air quotes, of your free monad or your free functor. So if we look at how that turns out in code for specifically a free co-free example, this might actually not be the... Oh wow, first of all, that's just the gist. That must have been some of the early thinking. I think we need to see a free monad somewhere. I think this is something that I can infer. It's not super well. It's not a focus of the text here. But if I take a general, actually there are other free co-free monad pairing articles that make this a little bit more clear. Right. I mean, I don't particularly like this one, but that's the one I was thinking of. So this is the functor underlying a free monad. And it's a free monad where you can add an int as an action, and then it will return a boolean to tell you whether it's reached the limit or not. And then you can also clear. And so the k here is the type parameter for the base functor for free. So anyway, I'm trying to explain free functors at the same time as I'm trying to explain all of this. It's impossible to do this. But basically here you have sort of three actions in this free functor. You can add, you can clear, or you can ask for the total. And these three actions are sort of movements. In this pair, they correspond to this side of the equation and the free aspect. And because it's decomposed when you have a free monad there, because it's decomposed in the fact that your functor is a union type, so you have add, clear, and total. Well, that corresponds exactly to a comonad that will have those three same things, but as a product instead of a sum. So is even the co-free comonad explicitly? I'm not even sure whether it's written explicitly here. No, it is, yes. Co-adder. So that's the co-free comonad here. Also the other side of the pair is defined in terms of a product, whereas so here a record, whereas the base functor for the free monad was a union type. Here the base functor for the co-free comonad is a product type, and movement in this co-free comonad sort of has to, in some sense, consider all possible options. It's like all of the possibilities of moving to the space, whereas the free monad is sort of telling you which step it is being taken each time. And so this corresponds a bit to an action, which in this sort of human computer interaction, or actually it's the previous diagram was better for this. It comes from this outside, so to speak, right? This external world. The external world generates something that's going to be interpretable as an action. And so it could be your user that clicks on something that adds, or click on something that clears, or it could come from the network. Somebody, something else could ask for an add or clear, or even a timer could ask for an add or clear. But it's the external world that's generating these actions, which then mean that your program then starts to move through a space of all of the possible things that can be reached by all the combination of actions and all the parameters that can be given to the actions. So this part of things sort of defines the vocabulary of steps that can be taken, and the comonad describes the vocabulary of spaces in which these steps can be meaningfully taken, and therefore there's the state transitions, or the space of state transitions, and how they are interpreted. And the amazing thing about this is that basically it boils down to, when you do it in free and co-free, to have some actions and then an interpreter. And your actions are defined in this monadic language, and your interpreter is defined as in this comonadic language as a co-free functor. And if you have a free and a co-free, the amazing thing is that you can compose them. So you can build up like larger free made of like smaller vocabularies, and then you can then follow the types to build all the interpreters that you need to interpret these increasingly complex, larger languages made of smaller languages. You just have to build larger interpreters made of smaller interpreters. And to me, that's a beautiful pattern. And I want to use that. And the reason why I went off this tangent is because there is a way to detect here what is the pattern that occurs. And it could be, it's not the incremental pattern, I don't think. But there is a pairing here. That's not necessarily obvious with the API. But if we can spot the pairing, then possibly we can build an adapter to adapt between the more free co-free world, which would still need to adapt to this streaming world. But that's the thinking that I was trying to do before, and that's why in my log I say, talk to me about Purescript run streaming, because Purescript run streaming is exactly it's basically it's coroutines, so exactly like this stream here, but using a language of extensible effects that mean that you can write, that really you can think of each that you can. It's not really, to be honest, I don't think I've seen this elsewhere. But what I was thinking is that, and I tried to write some code and I haven't shown yet, but that you can write these lower layers. You can, because producer consumer, that's actually quite a lot like in this world of data flow. And sources and sinks, and so that's really in this world. But then to me it seems like you can then say, okay, well, how about this is or these are the actions, and your program is basically just an interpreter, or the program really maps actions to other actions but through an interpreter. And so that you build this capability to use so the other bit that I haven't really talked about here is the fact that this uses a pretty advanced representation of basically what to me are exactly free and co-free. They're not exactly free and co-free. They have the right structure to do some types and product types, but instead of doing them as terms, you do them in types, and so that's more powerful, and it leads us to extensible effects. And the Purescript run streaming is built on top of that. So and invariance. So basically, you in Purescript run, you define your DSL, your free DSL, but instead of just generating a free, you generate a free functor from it, but you're able to. So actually, this is the traditional way. So this is how usually free is done. But when you have run at your disposition, then you can actually start building a type level version of that, which takes the same base functor, but instead of just passing it to free, actually passing it to fproxy to create a type level version. And creating a type level version of that means that you now can use Purescript's facilities to create records in order to do the composition of different DSLs. And that means that you have to do virtually no sort of lifting and unlifting and manual digging through the products, which you would otherwise need to do if you had a DSL. And I think this is this example that you start needing to hoist things and know which DSL you're targeting. So even though technically you can compose them with sums, which are here coproducts. In practice, when you write them, you have to do a little bit of accounting. Like you need to know whether you're lifting right or left, depending on which DSL you're in. Whereas if you use this variant form, then you don't. Then everything is done at the type level for you. And you see that now you can just speak and eat instead of having to lift left, speak, and lift, right, eat. Even though those are from different DSLs, now you can just call them directly. And that's the kind of the holy grail of UX for, well, in fact, both. I mean, that's something that you get from the MTL and monadic stack transformers, but that's something that you also get from extensible records and variants. And so that's a really pretty way to compose things. And with Purescript run streaming, you get this really pretty way to compose things together with the machinery to do streams. And so now the only thing that's kind of missing is, okay, well, now then you can just do the pairing thing. And then you can hook it up to a UI library. And that's kind of been in the back of my mind for a while. And actually, let me show you some of the code that I have on that, the one that I said that I hadn't shown yet, because I think it is time. All right, I told it to workspace. I think this is in shared and in experiment. And it's not. Okay, this shouldn't be empty. It must have not finished to replicate them. I think things is not running. Start it. Right, I have it in fact in a folder somewhere in C, or it's in program files and things. And here we go. And shared is scanning. It might not... no, it looks like it should be... It looks like it's actually good. So what's up? Maybe just the workshop thing isn't what I think it is. So yeah, let me find it elsewhere. I think maybe I put it into libraries. I know some of it I had in the update monad, but I think ultimately I might have put this into this kit project. Why is this empty as well? You know what? I mean, I'm at folder to workspace. It might be just filtering on folders, and I might not be realizing that. Or my yeah, no, it indeed is not showing the. Yeah. Okay, this is just filtering on folders. So. Okay, so why don't I just attach shared? Yeah, I'll just attach shared. And let's go to workshop. HKD. That's not it. That's it. Yes. Yes. Okay. So I'm going to refresh my memory. I haven't looked at this in a while, but this is what I'm talking to you about. This is an attempt to put all of these concepts together, where I have drivers in the sense of Cycle.js, and drivers are this external stuff. They're the stuff that generates events and interprets events. And so I want those to be composable in the Purescript run way, right? In like the free DSL way. So I want a bit like where was it? Dinner and right, dinner and talk. Right, talk and dinner here. Here they create a super type, which is talk and dinner together, and then they're able to use speak and whatnot, right? So I want to be able to have different drivers that I can hook together and that are in charge of basically mediating the outside world with our program. So okay, since I'm down the rabbit hole, I might as well continue and talk about this. I think that there's a perfunctorial structure to this as well, which is similar to the one that you get out of a monad transformer stack, which is like kind of a towery sort of thing, which is like, in fact, now you have your external world is really here. And driver mediates thing to the external world, and then the driver then talks to the program. And you know, I like this representation, but I think it simplifies something where, in fact, you can have multiple layers of these things. Meaning, in fact, I think when you write a program in this style, you end up having a main that takes all of the output and output all of the output, and then inside it kind of splits certain sources into certain components, splits certain other sources sinks, so that they only emit certain things. So there's composability in a fractal way inside this main, but then there's arguably, and I think it's something they've been looking at, but less composability on the driver side of things. Whereas it feels to me that in fact, those could be made as like the same abstraction, except, but unfortunately, making them the same abstraction means that your key building block becomes a little bit more complex, because you can't, and it becomes complex quite a lot in the way of Haskell pipes and conduits, in the fact that you end up having bidirectional bidirectional components. Doesn't this have little diagrams? I thought this had little diagrams. Yeah, it has little diagrams. So you end up mapping to this idea that there's everything has a way in and a way out, in addition to being composed together. And so in reality, in my view, like, and this is not a bad example, is like you kind of shift this diagram a little bit on its head, and you say, well, actually, this is where the end user is, and this is the driver, and this is one layer of my program, and this is another layer of my program. And it could be that at the end, it's kind of capped. And then maybe that's some business logic in some sense, where it doesn't, it's kind of pure in some sense, that it depends on some inputs that it gets, and then it just produces some outputs, but it doesn't depend on anything else than these inputs and these outputs. So I've been thinking about this architecture, and I've been wondering whether, in fact, the proper building blocks for that isn't something like exactly like Purescript from streaming. And so I've been playing with that. And so here I have an example where, what do I have? In my main, I get some model. What is load? Okay. Load comes from a model that I didn't include here. I didn't include it here. Okay, so let's go into where this comes from. I think maybe it's Git Purescript, isn't it? Yeah, drivers, data, maybe an experiment, some stuff. This is a mess, but that's fine. Component, application maybe. Yeah, application play model. Here you go. Yeah. So load does what? Load is not here. Instances. Right, so there's this idea here that something fairly ambitious again is that maybe there's some aspect of live data migration that occurs. That's a much more even advanced thought, so I'm not going to get into that yet. But you know what? It connects to something else that I've said earlier in the stream, and I'm kind of revealing some stuff that I haven't talked about yet on stream, which is the reactive notebook aspects. I think that reactive notebooks it's kind of this, it's pretty much live programming. It's the same as live programming. Okay, and live programming. If you program live and you add new data types, then you kind of want to each time migrate over your underlying data, and that's kind of what reactive notebooks are. And there's a kind of a progression in time and in data and like generations and migrations. That's well, it's really ambitious, but it's an interesting thing. And some folks have been doing really interesting work on that. And I think there's a way in which all these things join. So hypothetically, we would be loading some model. And then here, what do? It's I think it's only Node for now. I haven't hooked up any. This is great, actually. That's a great place to start, because if I, the reason why I'm talking about this, because I kind of want to make this converge with browser kernel right now, and that would be a prime. Even though it's fairly half baked, at least it's my half baked stuff, and then I can continue working on that. And one of the things that this didn't do, or for instance, is do any user interface stuff. For now, it was just doing console stuff. So that should mean that I should be able to run it fairly easily. Shall we try this? Shall we? I mean, that's ambitious, but I think I will need to do that if I'm choosing it as a possible way forward. So space build code iOS git Purescript. Okay, and so that's the root, and that's going to require some heavy npm install. So let's leave it be, and let's continue reading the code. So here I'm just trying to see what it would be concretely to pass some environment into the program. This is some housekeeping just to get a node console stream, like a readline interface style thing. And then I run off, and then I pass my user as a reader and some state, and this is really the program. And here I make a driver from my interface. So I take something IO and I pass it into my driver, and then I chain this and feed it to what is my program. Is log prime is my program, and my program is defined in terms of this Purescript run streaming DSL. So it's in the run monad, and it has this base type together with some annotation. And so here I'm not exactly doing quite yet this style where I define a DSL, but right now I'm sticking a bit to the Purescript run streaming way of doing things, where that's unfortunately not useful. There isn't really an example, is there? No, there isn't. How did I figure this out? I think it took me a lot of time. I had to study run quite a bit. Anyway, so the annotation here is the annotation that is required by run streaming, and that says, there's basically tells which type of coroutine each layer is doing. And so the driver prime, so here we only have two components. I was telling you that I was thinking about the fact that there could be more components, and in fact I tried to start going that route here, but I couldn't quite make it work, I think, or maybe I could, and I was just playing with another path. But here there's something similar where I was trying here to do composition. I was struggling a bit because basically the await and yield and the type that go inside them become sort of the interfaces for these arrows going back and forth there. And what is my base type already? My base type includes the capability for each of these layers to also have effects, to access the environment through a reader, and to also carry state. And so here you can see that there's some kind of orthogonal interesting thing going on, is that I have both what looks like a monad transformer stack paired with this concept of actual pipes, but I don't see them as pipes. I see them as layers. So layers in this sense. So in fact, I realize that it could be that maybe only the drivers need to have side effects, and then at some point everything can be pure up there, like it can be a pure data flow, but maybe still access to the environment, and then access to state or not. That's where things were getting quite interesting, but also difficult. Especially if you add what I showed you before, this idea of actually loading and doing migration for state, right? This is super advanced. It's going to take me a while to do anything with that, but possibly I wouldn't need to have my base monad. I wouldn't need my base monad all the way to the top. I would have maybe a driver monad that would have effects, and then a component monad or pure monad that wouldn't. That's a thought. Though I don't know how it would work type-wise. I think, but yeah, no, I think it would actually I think it would work quite well. But there's something still I haven't shown you, which is how they then mix in all of this commodity UI aspect, and how I do the mapping of a free and a co-free. So here we need to see that, in fact, one of the things that I've chosen here is to say that this pairing will in fact occur at the level of an interaction between layers. And an interaction between layers is defined as a request-response pair. And a request-response pair is something like, you can see, for instance, here in a very simple way, but maybe it's better to show it to you here. Hey, do I do code reviews? Oh, incredibly knowledgeable. Thank you. That's very nice of you. I sometimes do code reviews at work, and this is some of the most advanced stuff that I'm working on, and you're joining this stream at a point where I decided to air it for the first time. I've been working on some other stuff, but this is sort of the stuff that's in the back of my mind. And all of this is, the very limit of my current understanding. And it's a bit of a mumbo jumbo of all of the most advanced stuff that I know about from Purescript and Haskell and all of that. And trying to link it into something that, after learning for a while, I thought, hey, couldn't you do that maybe? And trying to convince myself that maybe you could do that. And, I think that it's a good idea, but I don't know quite yet. How about you? What do you do? Oh, thank you. I really appreciate it. A little project. Hey, shoot it. Yeah, I definitely, I'm a small streamer. I'm definitely interested in interaction. So if you have something for me to take a little break and look at, I'll be happy to do so. Absolutely, they are. So I'll just finish my thought, and then I will jump into your code and give you real-time feedback. Cool. So let me finish my thought. So, So what I was saying is that this request-response pairs is what I think becomes the interface between this producer layer and maybe transformer layer and consumer layers, right? It's seen as this kind of layers there. And so it's a little bit like but it's not, yeah, it's not exactly sources and sinks. It's sort of a unification of sources and sinks, so to speak. It's a unifying interface for sources and sink that's a little bit more opinionated, maybe you could say, because basically the await well, okay, it's a bit tricky here, right? It's so the await yield pair defines what, so yield here will connect with the bottom and await will connect with the top. So the yield of the top gets interpreted by the bottom. And then, so if I have a layer further underneath, then I will yield some stuff below, and then the layer below will also respond to it. So here I haven't fully fleshed this out in this example, but I think in the more simple one that I have here, I think I have. I think I have a response, a respond rect prime rest prime. And so in this example, let's see, I have my driver feeding into my log. And so my driver yields a response request and a string. And then my log prime only awaits for the string. Okay, right. So that's where... Oh, so I think in this case, I wasn't quite able to make the interface do exactly what I wanted. So I think maybe I haven't exactly succeeded in doing the vision that I was just telling you about. But these are various attempts. But with this simplification here, I'm still able to actually pair a request that will come in from my driver and then interpret it with this co-console interpreter that's written in the style of Purescript run. So in this style, but the pairing is coming from the commodity UI idea, or like the free co-free pair. And so I write my interpreter is a product type, like I was saying. So that's the co-console, and the console should be in types, I think. Yeah, so the co-console is put and get, and then the console is again put and get, but this time as a sum type. And so these two things basically define, as I was saying, like basically you have some layers that are sending put string actions and get line actions that comes from the external world, and then your program has a comonadic interpreter that's actually dealing with them somewhere higher in the stack. So so I'll try and implement or hook this idea up. Well, first of all, I'll try to make this run and see where we're at and explore it a bit. And then I'll go back to our prototype and see how we could plug this in, and also which UI framework will fit the bill for this. So that's it. That's me finishing my thought. Let me drink a bit and go check out Define Null's code. Let's go check it out. This looks like an assembly language, but maybe also a bit like this looks really like an assembly language. Okay, I'm gonna drink a bit. Yes, I am colorblind, but actually I'm quite good with this. I can see the comment, the green comment and the orange link fairly well. I think maybe there's a difference between the int and the label here. Is it yellow and orange? Maybe it's slightly different, right? But this is not super obvious. I think the red, orange, and the yellow, that's tricky. And but the green on screen like that on a black background, that works. Anyway, okay, C15. Metal is a physical 100 mm based on the fictional architecture. Hey, switch it to 32-bit Y, register AB, register R is for arithmetic result. For flags, 0 greater than. Built-in subroutine stack with a maximum depth of 50 items. There's a secondary stack that is also 120 items. Press run to assemble, compile, upload, and execute the machine code. Oh yes, that's upload, beam, and it's telling it it's running on this virtual CPU or virtual processor. Very cool. Ah, numbers are green. Yeah, I said yellow, and I so like it's a different green than that. You see, synthesize a real CPU, made your own arch, and made an assembler and compiler on the web. That's awesome. You're running. Oh, I'm running the code on the. Well, I'm running the code on my GPU in that case, because yeah, because it's interpreted in JavaScript, and it's just a virtual CPU, but it's running in JavaScript in the end, or in WebAssembly or something. Oh, real CPU at your house? No way. But so what's the CPU at your house? You did. I like the effort you did with the interface design there. Oh, nice. Very cool. Yeah, I love FPGAs. That's so cool. So you know the Haskell folk have been doing some interesting things about that I think you'll be really interested to learn about if you don't know about it already. Conor Elliott in particular is really one of the really bright minds of Haskell. Has been looking at compiling to categories, and in the context of that has been looking at something like a stack-based language. Calculating compilers categorically. And he made a talk about it as well. So I'm definitely going to dump that. Well, actually, let me dump this whole thing into the chat. And we can take a quick look at this. So this is a stack-based language. And it basically points out like some really deep mathematical sort of conversion between, in fact, like what you could see as the essence of machines and what we make machines do, which are basically stack-based operations, which is really what is happening at a really low level in any processor. And the mathematical language of what I come to see as basically what the human mind, the way the human mind thinks. And so this to me was it's amazing because it's really kind of the rubber of the mind hitting the road of the machine architecture. And Conor Elliott is has built up some Haskell code and is really looking at this kind of stuff of how do you compile this purely functional programming language into not just optimized code, but into hardware. So so I think you'll be particularly interested in that because if you do FPGAs. And there's other stuff that I want to point you to as well, if you're interested. I think it's concat, yeah, concat. Is it? Yeah, concat. Yeah. Right, there you go. You can check out your compiler. The human mind was just in your network, haha. Yeah, it might be a neural network seen from the outside, but I'm talking about the subjective experience of the human mind. Oh boy, compiling straight to hardware has so many issues, timing bugs. Yeah, exactly. So that's so important, and so look at this. So this is a set of things which include a plugin for GHC, for the Haskell compiler, in order to be able to do things like compile code to visualizations, compile code to like some application, like doing circuit graphs, GLSL, like to shaders. He's done some work about how that could work in a machine learning context, and so circuit graph, I guess, encompasses hardware, and so this, for instance, spits out Verilog, right? And so the thing that that if you haven't seen, you totally have to see. It's from the Functional Programming Language Conference. Okay, I forget what it's called. Functional Programming Language Conference, hardware, ICFP. That's it. It's ICFP. ICFP hardware, and that's yep, that's it. So this is from Pat Harahan in 2018, really talking about the future of hardware because of the motivation is the end of Moore's law, and the fact that, and this guy, he's been very successful. He has an Oscar because he, like a movie's Oscar, because how do you call it, we call it an Oscar in France. Academy Award. Yeah, he's an Academy Award winner because he built RandomMan shading language, which is used by Pixar for all of their. I think it's still in use, but for all of their early movies, including Toy Story, I think that got an Academy Award. So this guy did that, and then this guy did Tableau. I don't know if you know Tableau, but Tableau has been like super successful data science-y UI thing. Right. Yeah, exactly. He's totally no joke. And then he's saying, well, end of Moore's law, right? That's what we're facing as an industry, right? And so he says, well, the way that you continue breaking that is by doing dedicated circuit design, because microprocessors are too general purpose. So if you want things more efficient, you go to DSPs or ASICs or dedicated hardware, right? Yeah, exactly. Parallelism, but he's going even further than that, right? Yeah, parallelism, but still for general purpose programming. Indeed, GPUs are totally awesome, and you can do tons of stuff. But this idea of, okay, I got my program, now I'm going to compile a hardware circuit that's highly optimized to solve it. That could get some amazing speed ups for certain applications. Yes, exactly. Specialization. Yes. Although here the idea is, where do you fit? I mean, the fact that there's a wide spectrum of things between general purpose programming languages and general purpose microprocessor architecture, and then specialized purpose architecture. And FPGAs are exactly that, right? FPGAs are reprogrammable hardware architecture, but they have some issues, right? They're not as fast as some of the highly optimized microprocessors. But what these guys is they're coming to as a comment is how, even in 2018, how backwards all of the hardware definition stuff is. And so, I hear you when you say screw VHDL, and at least this Verilog, is because all of that stuff is actually way behind in terms of more modern practices in software engineering. And so he's saying, please, Haskell folks, and basically help make this more of a reality by doing synthesis of circuit in a way that deals with all of these space-time, like time locking issues that you're saying. Right, exactly. It is behind. And so I'm really glad that you're interested in that, because when I saw this talk, it really opened my mind like really big in terms of, possibilities and I guess the next 20 years of hardware, right? Rather than doing same old, because there's really some compelling stuff going on with dealing with space-time in a very principled way, that I think only functional programming is doing. And what I'm thinking about specifically here is Turian's work with Ryan and type level clocks. And so that stuff is also really at the edge and pretty amazing. Speed is not even the issue. Sensibility could be a big issue with custom circuits. Yeah, in some sense, we could go back in time to have expansion cards. Yeah, but GPUs are like big expansion cards that are hyper specialized for heavily parallelized programs. So it's not like it's not going to work. But yeah, you're right. I think so. I mean, like silicon production is still super specialized and requires like heavy lifting industry-wise. So it's not tomorrow that we're going to be able to 3D print an expansion card from home, right? But who knows, maybe 50 years, it's possible. Yeah, PCIe, yeah, exactly. So check this out. This is a library that basically allows you to define components. And here there's software components, like we're not in hardware anymore, but I want to talk just about this idea of space-time programming or scheduling and synchronization, which is a super important issue in hardware design, right? But it turns out that it's also a super important issue in anything that has streams. So any video streaming, audio streaming, when you want to combine things, when you have, like when you have UIs that have an event loop that refresh, like request animation frames, anything that's in 3D, that often you end up with, or interrupts even when you go down to the hardware, right? It's like all of these things are basically conceptually different clocks kind of working, that you're trying to compose different clocks. There's certain clocks that work, at the frequency of your hardware. Some of them that are actually asynchronous because they like interrupts at the very low level, and then also you have others that are that might be linked to buffer and processing times, some that are just subdivisions of existing clocks and whatnot. And this stuff is just super hard to think about, right? And super hard to get right. And I think that this approach here with Ryan, this is actually super, this is pretty much, I think, the principled way to deal with this. It basically says that, okay, if I have two clocks, they're basically two different types. And then then I can assemble them in my program together as long as I have basically a conversion or a way to deal with the composition of these two clocks. And so, but the thing is, like, it's not just two, then you can scale this up to many. So you have, lots of code to write if you have 50 clocks, but you're guided by the types. You get type level programming for that. So now, this is an example. You've got here a clock that runs every 500 milliseconds, and here a clock that runs every 1.2 seconds. And then you can, using this, it's hard to read, but this is like arrow-based programming language. You can basically sort of compose these streams together in such a way that you have a completely deterministic output. And I think that that's really what we need for difficult problems of synchronizations of clock. Oh, that's nice. PCIe capability in FPGAs. Yeah, I'm not surprised. I think I've seen some of those actually. Like, isn't there something like Volcano or something like that? Like Tornado? Like some of these FPGA cards that are used in academia to do research on that. No, I'm not from academia, but I have huge respect for academia. And I've done I've done software engineering, not looking at academia for 20 years. I wasn't even interested in looking at it. And then I discovered functional programming languages like Haskell and Purescript. And then after, 2 or 3 years of studying them, then I was starting to read papers. And I was like, what? And then I was like, wow, I'm starting to understand that stuff. It's pretty amazing. That's super cool. Yeah, man, your web app is so it's really as you can tell, I'm inspired by it. It's really awesome that you're doing this. So let me read a little bit more about it. So processor contains 3 registers, all 32-bit wide. ABNR, 4 flag, built-in subroutine stack with maximum of 50 DAC. Yeah. So would you say that this is a kind of a toy example for you to understand microprocessor architecture and FPGAs? Or do you think that the architecture that you're building is actually something that you think has some, like, it could become something that you think brings some unique, something unique to the table that doesn't exist with existing architectures? It's a toy architecture. Yeah, that's the best to learn. I mean, that's amazing. I mean, yeah, I love to do that. All of my stuff is toy-ish, I mean, but basically, I find that that's just the best way to learn, right? That you get hands-on and you try something specific. That's really the best way. Unique thing that you've never seen in other art. Hey. All right, yeah, talk to me about those. Second time in the editor. Let's check it out. Calculate the nth Fibonacci number. Run. So that looks quite different than the first tab indeed. This looks like more like assembly, and this looks like more like JavaScript actually. The DevTools console. Sure thing. Right, so that's the compiled, right? That let me rerun it. You see the output of the compiler. Oh, maybe it's in cache. Let me reload. Yeah, I think it was in cache. Right. Okay, let's do that. The previous number equal okay, let's make a new sequence. 2. Okay, so right, so you're compiling this down to, yeah, that's amazing. Have you seen like there's someone in the Purescript community that's building a WebAssembly backend. Wasm in Purescript. Christoph Hegeman, who is Kritzkrieg on Twitch. Totally recommend that you go watch it. He's super smart, and yeah, I don't know if he's been twitching regularly these days. I haven't seen him recently, to be honest. I wonder whether he left it aside. But check out some of his YouTube stuff. Really interesting. Learned a lot about WASM through that. Right, so you vpush 18. Okay, what is vpushing 18? Let's check it out. Vpush. Pushes a given value to the stack. Call, push. Vpush is documented. Haha. Yeah. Immediate 12-bit push. Okay. So that's the, yeah, that's the. Oh, so you start by That's interesting. You start by pushing the argument on the stack right away before even doing anything, and then you call the function. Right, and the function then is a label, and then you pop potentially I suppose the result, and you do get a load the value on the stack. Okay, so right, so function Fibonacci is going to put the result at some address A0. Calling convention stack base, yeah, makes sense. And so you pop you pop 18 in variable, and you put it in this variable Fibonacci n, and then you store some stuff. QStore. Haha, undocumented. Store value address. Okay, so it's a quick store. Something. A0 is just .code.data +1. Right. Just to about where things are in your let's run this. So the low level instructions. Right, you're in your memory region, right? That's the memory regions. So you have .code is as 21 size, and then that's .data, I suppose, your registers, and then your .data is your memory, maybe. QStore is immediate store to a bit. That makes sense. And so yeah, you put 0 into this variable name, and 2 into this variable name, 1 into this variable name, and then you loop. Yeah, which is this thing. And yeah, you get stuff and do some complement with those two things. Yeah. You know, I haven't written writing a compiler is something that I haven't done yet, and that like Haskell is supposed to be best in class for compilers, so I will do it at some point. And actually, some of the stuff that I was talking about when you came in, I've been thinking about the sort of just-in-time compilation implications of some of that stuff. So that should be interesting at some point. And yeah, cool. And then the data, the .data stuff is in there, and it ends up being displayed here nicely with the addresses. Super cool. Oh, and resources used 36 as a 501. Is that your number of FPGA cores? Rerun it again. Ready to upload. Boom. And go to the source window. And compiler. Yeah, that's awesome. I suppose then there's something interesting going on your local computer on the server side, right? Did you publish the server code anywhere? It's the memory. Right. Yeah, that would be a whole other thing. Yeah. So so is it just one FPGA? No server code published yet, right? Because you're taking the output. You're taking all of that we see on the console, right? Like the assembled the assembly and the variable, and your server takes this and then converts this into FPGA instructions. Or because those aren't FPGA instructions, right? C++ WebSocket server that uses OR to program the CPU. Cool, cool. Nice. That's awesome. That's an awesome third project. I love it. It's very cool. You know, something that I've been thinking about in the lineage of this talk and like specialized circuits is the idea of analog circuits to do certain type of calculations, like the differential equations, for instance. Like you could plug in oscillators and like, you know, sine functions, signals with an infinite resolution in an analog circuit, and then you'd set the frequency of your analog function, by setting some oscillator, like a hybrid digital analog circuit, right? The output doesn't seem to be right. Which output? You use oscillators in FPGA to make the random instruction. Yeah. Also, it has like a, yeah, of course it does. The runtime output. Go up on the right hand side. Aha. Good. I have the tester instinct, you give me something and I will break it. Oh, hold on. You know that I changed 2 to 1 here, or 1 to 2. Remember? Uh-huh. All right. No need to open your, no need to take your oscillator to take your your oscilloscope, and no, it's all working. Timing bug, right? Yes. I imagine you with like a spelunking light, like opening your opening your machine and like plugging in like your oscilloscope. Yeah. I can imagine. That's very cool. Where are you based, if I know? Canada, nice. I am in Berlin. Oh, well, I think it's in my bio, right? And you've read it because you know that I'm colorblind. Right, so I was saying, like this type level clock thing, I think this is the solution to timing in general. And, just to give you some credentials for this, the guy who developed this, Turian, is building on existing work from the guy who developed Junai. And the guy who developed Junai, Ivan Perez, he is now working from NASA to use his using his framework, which doesn't have type level clocks, but is this pretty advanced and smart formulation of what's called functional reactive programming, like a reactive framework to dealing with events and whatnot. But now he's doing this for NASA. Specifically in the idea of creating fault-tolerant swarms and fault-tolerant functional reactive programming and runtime verification and validation of functional reactive systems. So super advanced work there based on some of these concepts. And, not enough people know about this. And this, I think, is going to be really important for a lot of stuff. Like, look, formal verification of system state for spacecraft automatic maneuvering. Yeah, of course, it makes sense because these are complex system that interacts with different events, listening to like multiple systems that need to compose with each other, that all have different clocks, different error margins, and to build a highly resilient system like for critical infrastructure, that you need to be able to formally verify that your specifications are actually within some of the tolerance margins that you want, like in terms of mean time between failures and things like that. So yeah, that stuff is super exciting to me, and I want to get there. And one of the more researchy questions that I've been having is how the stuff that I was talking about before you arrived, the Purescript coroutine thing, the run streaming and the coroutine. I'm sure that there's a formulation in which it's possible to add to these type level clocks. The reason I think that is because things start looking a lot like monad transformer stacks. That the fact that adding those DSLs on top of each other, even like in the code that I was showing, like the fact that these where was it? Yeah, that these requests, that these base types that I was mentioning, they carry basically effectively monad transformer stacks, reader, states, blah. So actually, I'm starting to see, just talking about it like this, I'm starting to see what it might be. Because in the Dunai formulation, a monadic stream function, like reader, for instance, is really the one that, okay, this is a hard type to parse. Okay, let's go to the not here. Monadic string function. I think maybe just the monadic string function type, the data type. It's in core, I think. Actually, it's defined in internal. Yeah, it's a bit hidden, but yeah, there it is. So the whole idea of this type is that you can use it with reader t of time. So for us, it would be just reader of reader time here, in order to make this into functional reactive programming. And then you can add layers of capabilities on top, what I see as on top, to add different capabilities for your, I guess you could say, your signal network, like the possibility to have non-determinism outputs for use, or carry state, or even this idea of and from there this idea of synchronized signal come in. So yeah, I think I can't work it out now how it will work, but I think it will be somewhere around the type of how I was saying, like that requests and the type of requests and responses pair. Yeah, it's this thing. Okay, I'm going to write some notes about this, because now that I'm going back into it, I feel like before I sign off, which is going to be fairly soon, I will want to write something down. Oh, that's nice. You made the project to get a job. Well, yeah. I mean, I assume from what you say that it didn't work out. Well, I'm really sorry that it didn't work out. I hope that you're not discouraged and that you're still looking and that you'll get plenty of opportunities. Seems like super cool project. And oh, you haven't started looking. Well, then you gotta finish school. All right, that's cool. That's very cool. Some of the stuff that I've been showing here, I also use this to as a sort of interview material for the job that I recently been hired to. I actually I had the interviews in December and I started in January 1st. So it's only been about a month and 10 days now. But it's my first job doing functional programming. So I do lots of OPSI and more system engineering things with Kubernetes and whatnot, but I also get to do Haskell. So I'm really happy about that. And I feel like with the streams, I feel like I'm at school all the time. I'm still learning all the time, except that I get to choose what I learn, and that's awesome. A decent project to show off. Totally, man. Yeah. Hey, Montogi, thank you. Really appreciate it. Yeah, having a Haskell job is awesome. Really proud of that. Thanks a lot for the follow. Really appreciate it. And yeah, Define Null, it's more than a decent project to show off. It's super cool. I mean, I find it really inspiring. Folks who just joining, Define Null was showing me his VLDR project, which is super awesome. I'll describe it in a bit, but you have the description here. But it's an assembly language, a compiler, and then an architecture where you can actually run the compiled code on his FPGA, where he has an architecture there, which then runs the code. So don't spam it, right? Because it's only one FPGA with 500, 500 kilobytes of memory. But that's super awesome. Yeah, you know what? You should even have the napkin, a picture of the napkin. That's that's a super cool project. Oh, hey, you check this out. Woohoo! Nice. Hey, you have a. It's long gone. Yeah, nice project, right? Yeah, I didn't do this. Define Null did it, and yeah, it's doing good. What's your other project? Uh-huh. Yeah, you have a business head on you, huh? That's good. File storage experience crafted to suit you and your needs. All right, I want one. That's cool. So your stuff is on the CPU. Yeah, very cool. Feel free to drop the link again in the chat if you want other folks to look at it. And yeah, absolutely, you will get a. You still don't know what subfield you want to work in. Yeah, well, the world is your oyster, man. Pick. I mean, yeah. Find something that you're really passionate about, because that's really what's going to carry you in the long run. That'll be my advice. Messing around with designing, that's great. That's fantastic. All right, I'm going to write a few notes based on some of my rambling on basically what you could say is maybe comonadic coroutines with type level clocks. Okay, that's a crazy thing. But what I was saying is that maybe Low level will be nice, but finding work for that is rather hard. Yeah, indeed, indeed. Well, try and check out what Pat Hanahan is doing. You know, follow this guy on Twitter. Look at what's happening, because I think that's where the future of hardware is going. So if you want to do low level stuff, then keep an eye on this corner of the world, I would say. Okay, so what was I saying? I was saying something like, okay, in the stack, like there's something about an equivalence between like the monad stack, the monad transformer stack, and the the extensible effects that are in Purescript run. That's an obvious thing to say. But there's also something a bit like a monad transformer stack in Junai as well, and Junai and Ryan, except not really, except like it's more like a tilde here, because the way that this stack impacts the functional reactive programming language or architecture or features is really super deep, and it has pretty much nothing to do with the monad transformer stack. I mean, nothing is not true, but the fact that reader T of time, for instance, gives you FRP is not something that you would necessarily expect. So I think that this basically, one way to say it is like this relates to the time semantics, or maybe to the event semantics, right? Gotta go. All right, Define Null. Thanks a lot. Yeah, really good to see you, man. Hope to see you in some of the next streams. All right. I wanted to check out how it was explained, for instance, in I think the paper is where it's the best explained, to be honest. So maybe we could check out the paper. Paper mirror. Right, paper would be here. Refactored. Here, PDF. Yeah, reader becomes. How do they frame this? You say parametric on the play position. Pass the play position as an argument. Get myself a new reader environment from the input signal reiteration. Temporal running function, run reader T from time. MSF applied to monad of associated temporal running functions. They kind of call it temporal running function. I need to dive back into this. I think that's what I will do next. So I will dive back into Junai. And then I want to then dive back into my play code, which is like Purescript run streaming code. And then I want to choose a UI framework again based on that. And it could be that it's just React Explorer. Probably will be Purescript React Explorer, because that's actually a way to plug in React and the Commodic UI. way of doing things. And so, yeah, because there's one of the interesting things is that there's a lot of sort of seemingly orthogonal but then rich in interaction concept, right? There's the monadic action, or even steps, you could say, paired with the comonadic space or interpreters. Hey Jill, how are you rating? Thanks so much. That's so appreciated. Awesome. I'm actually going to be signing off fairly soon. I'm definitely at the end of my rope and trying to make a little list of things that that I want to do next time. So appreciated. Hi. Yeah, so I've been going off the deep end, looking at some of the old work that I've been looking at and trying to see how I can fit things together with some of the Purescript prototype that I've been working on. Stream been okay. You know, I've been investing a lot of time in a new computer, which has meant that I've been spending some time installing NixOS on stream instead of doing Haskell. Yeah, I do some Purescript on the Thursdays. I do this is my stream schedule. On Tuesdays I do Haskell, but that's been a bit kind of taken over by me trying to set up a Haskell developing environment on NixOS. And then on Thursdays, like today, we're working on Purescript, and we started working on Chronofold, which is a real-time collaborative text data structure, like a CRDT. Yeah, Nix is the rabbit hole, but it's so pleasant to do something that, you know, uses this concept of functional purity applied to deployment. I can already feel that I like it, right? It's just that it's takes time to learn. Yeah, so, you know, on Thursday, the Purescript stuff that we've been doing, and I've been developing a first version of a library for this data structure, Chronofold, which is a CRDT, and it's really supposed to be really efficient for text. And then started working on a prototype for that. And then recently realized, like, oh, I want to plug in this prototype together with some of the other more prototypical stuff that I've been looking at. Like, do you know this library, Purescript Run? It's Purescript Run Streaming and Purescript Run. It's an extensible effects framework for Purescript. Yeah. And so there's Purescript Run Streaming, which is way less known and way less used. And that's just basically building on top of that, but to build a coroutine implementation. So very close to what you get with Purescript coroutines, except that it's all in the types. And so that's pretty amazing. Right. Awesome. Yeah. So I did a little bit of work trying to understand it and trying to plug things in. And you know, like I like to do, I've been cramming like lots of concepts into this, including things like where is it? Yeah, like Phil Freeman's comonadic UI stuff, and this whole notion of pairing a free functor with a or free monad based on a functor and a free comonad. Because when I started looking at this particular style of having a free monad based off of a free functor and then a free comonad doing the interpreter, I started being like, wow, this is really clean and I kind of understand it. And so I thought, hey, could you do this together with coroutines? And because it'd be nice to have a streaming aspect to this. So I've been trying to do that, and today I realized I've been off a way tangent trying to think, hey, I'm going to implement this into my Purescript prototype now. So yeah, so I've made basically virtually no progress on my Purescript prototype because I've been watching at my old code, trying to understand it and wondering whether I could actually plug that into my new code. And yeah, you guys caught me just as I was trying to make a list for myself of things to do next stream so that I don't completely go off way of a tangent and not follow up on things. So I'm gonna dive back into yeah, Dunai and Rhine, and then this piece of code, play, and Purescript run streaming, and then see if I can actually use some of the Common-Edic UI stuff that Phil Freeman did with React, and that implements this pattern of free co-free, but is also plugged into the Purescript React ecosystem. So then I can, plug in, use my React knowledge and use the React components for all of the UI stuff, but then have a lower layers that actually using free and co-free for interpreters, and then wire more event-driven code at the very bottom with run streaming. So that's kind of how I'm seeing things. And yeah, I don't know if it will work, but that's kind of the Frankenstein monster that I've been trying to work on next stream. But that's going to be it for me today. And so thanks so much, Jill, for joining, and everyone else. I'm sorry you caught things at the very end, but it's also the very end of my capacity to function. It's 10:30 here after to 2.5 streaming after an 8-hour workday. So yeah, catch me next Thursday if you want to do some Purescript thinking, or otherwise I also stream on Tuesdays and Saturdays. And yeah, I'll put a link to my Discord in the chat, because I think that's what the young people do. And thanks a lot for the follow, Jill. Really appreciate it. And yeah, I'll just sign off for now. Thank you so much, and bye-bye.